If possible, let's find the sum for this infinite series. We have the sigma when n goes from 1 to infinity, 1 plus 2 to the n, all over 3 to the n. Notice that this fraction, we have two things on the top and just one thing on the bottom, right? Why don't we break the fraction apart to see what we can do after that? So this right here is the same as the sigma when n goes from 1 to infinity, and I will look at this as 1 over 3 to the n first, and then plus 2 to the n over 3 to the n, like this. Well, notice that if I break this apart again, whenever you have two things inside, it's pretty much saying the summation of this and then the summation of that, especially if these two are both convergent. So I can look at it as specifically the summation n is equal to 1 to infinity, and then for this one, 1 over 3 to the n, you know the deal. I'm going to write this as 1/3 inside of the parentheses and then raised to the n power. And then for the second one, I will write it down as plus summation of that, sigma n from 1 to infinity, and then you also know the deal right here. Put down 2 over 3 in a parentheses, and then raise to the nth power. And the reason for us to do this is that we can be sure that this right here is a geometric series. When we have a number raised to the nth power, we also know that this right here will be the common ratio. I will write down R1 because this is my first geometric series. The second one, it's also a geometric series. 2/3 to the nth power. I'll write down R2, which is 2/3. And then we can get to work because 1/3 is less than 1, and then 2/3 is also less than 1. So we know these two series converges, right? So let's go ahead and compute the sum for this, and then we just need to add it with the sum for that, and then at the end, add them up. We are done. So this right here, I have to figure out what the first term is. I will plug in 1 to this n, which we have 1/3 raised to the nth power, which is 1. So this right here, 1/3 to the first power, we have. That's the first term. And then we put it over 1 minus the common ratio. It's going to be 1/3 from the first one. So that's what we have. And then that's pretty much a setup. And then this right here is plus. Right here, we put down 1 to n. We have 2/3 raised to the first power over 1 minus the common ratio right here, which is 2/3. That's pretty much it, right? And now we just need to do more computation to finish this up. Let's look at the first one. We have 1/3 to the first power, which is just 1/3 on the top, over on the bottom we have 1 minus 1/3, which is 2/3. And then we add it with this right here, just 2/3 on the top, over 1 minus 2/3, which is 1/3 on the bottom. And then to finish this up, this right here is a complex fraction. I get to just multiply the top and bottom by 3 so that the 3's cancel. So is this. I can multiply by 3, so the 3's will cancel like that. All right, for this, what do we have? 1 on the top, 2 on the bottom. We have 1/2. Plus, what do we have from here? 2 on the top over 1 on the bottom. We just have 2 over 1, which is 2. You can write down 2.5 if you really want, but then I will write down 5 over 2. This is it.